Hi, I'm Joseph, and I'm just starting a PhD in artificial intelligence. That's artificial intelligence, like making robots that can think like people. I want to do it because I genuinely think that we can make robots that think like people can, and I want to, and I think that that would be absolutely ridiculously awesome. So, to keep myself honest, I'm going to have a video blog every two-ish weeks, and in that I'm going to explain some of the things I've been thinking about, some cool things I've read, and etc. Don't worry if you don't have like a PhD in AI yet. I'm going to be explaining things right from the start so that it makes sense, what I'm doing and why and all that stuff. I'm going to be talking about today intelligence and rewards. I define intelligence as the ability to make optimizing choices. So you can think of that as if you've got a system which is an intelligent system, the intelligent system can take inputs and it can take in these these numerical values of reward. So this is sort of how happy it is. And it has to all the time be making choices and then producing output, which is those choices. The reward function input is this number that over time it should be trying to maximize. So it's trying to maximize, and it's not just trying to maximize the number, it's trying to maximize the long-term sum of that number. So you can think of this as the reward function is it's kind of like how happy the system is, and it's trying to get the best long-term happiness for itself. This is over time. I just draw the picture as if it was kind of one snapshot, but you can think of these inputs and rewards constantly coming in and the outputs constantly going out. We're constantly making new choices, new and perhaps better choices, because as we learn more about our world and as we learn more about how our inputs and our rewards work, then we can make better outputs and we can make better choices. Sometimes I'll draw this or describe this or use the words observations and actions. These mean the same thing as inputs and outputs. Like you can imagine a little robot running around and having a camera and microphone and stuff, and what it sees and what it hears is its observations about the world, and what it actually does, the actions that the robot performs, are its actions. I might also describe the reward as a goal. So you can think of this, and it is the goal specification for the system, but it's not just like, yes or no. The system doesn't end as soon as it achieves its goal. It's a continuous thing. So you can imagine it getting a bit of happiness whenever it achieves goals. It's just that describing it as a number and as a number over time means that we can do a bunch of other kind of nice stuff. But I'm just going to use the words input, output, and reward for now. You can think of the intelligence part of it as the choice. And it all kind of makes sense. It comes together. You've got inputs and rewards coming in, telling you how well you're doing and what's going on in the world. You have to understand the world and then make choices and then output. So the intelligence system itself is a choice-making mechanism. Because remember that intelligence is the ability to make optimizing choices. Our choices are choosing between our outputs, and we're optimizing with respect to our reward function to try and get the best reward function value. Sometimes I'm going to describe this mathematically. And all that maths means is add up all of the values of the reward function across our entire lifetime, and that number, we're trying to make that the best. So whatever choices will make that number bigger are the good ones. So you can think of it as if I offered you a cookie today or 2 cookies tomorrow, then you might decide 2 cookies tomorrow will be better because you'll get more enjoyment out of 2 cookies than just 1 cookie, even though you get the cookie today. We might also describe this continuously, and this means exactly the same thing. It's just mathematically this means that it's happening all the time. We're always making choices. It's not just sort of at discrete steps all along the way. And sometimes we make this a little bit more complicated. What this means is that the rewards that we get tomorrow aren't worth quite as much as the rewards we get today. And it makes sense because we might be dead in a year, or I might be in a different country, and I might never actually get your chocolate chip cookie. So if there's a 1% chance of dying every day, then discounting by 99%, or discounting by 1% kind of makes sense. And that's all that does. So I'll tell you some examples about intelligent systems. For example, we might have a chess playing program, and this is a chess playing intelligence. It sees all the time the chessboard, and it can tell when it's won, and whenever it wins, it gets happy. How happy does it get? Well, it gets, say, 100 points of happiness for every victory it gets. Its outputs, then, are the moves that it makes in the chess game, and it makes those moves to try and win the game, obviously, because the system's trying to optimize to get the most reward. It gets reward whenever it wins, so it tries to make moves in chess which bring it closer to winning. You might describe a vacuum cleaning AI. The vacuum cleaning robot can see, it's got sensors, it can see the dirt on the floor, and it drives around. We're going to give it a reward function, which is how clean the floor is, minus, if we run out of power, then we're going to get really, really sad, because if you don't make it back to your recharging station, then that's really bad, because then a person has to actually pick you up and plonk you there itself. So yeah, but aside from that, you get happy whenever the floor's clean. And as the floor gets dirty, then you rush to clean it up because the dirtiness is making you sad. Its inputs are the sensors, so it can see, and its motors then are the wheels and the motors and stuff, and that's its output. So that's what it does to try and clean the floor. And you can imagine all of these different AIs. You can imagine a chess playing AI and a vacuum cleaning AI and a sonnet writing AI. But ultimately, I'm not really interested in all of them. Remember right at the start, I said I'm interested in human-like intelligence. I'm interested in the kind of intelligence that people have. I'm going to call this generalizable intelligence. And the difference is, or at least as far as I see it, that people can do any of these tasks. A person can play chess and clean the floor and write a sonnet. And that learning and that ability to learn new goals or to be able to gain new abilities is incredible, and that's really, really great. Yeah. So let's talk about a little bit of philosophy. So I've defined intelligent systems as systems that take in inputs and take in reward values and produce outputs. They make choices in the world. Here's a question for you. Can an intelligence still exist without inputs? Well, by my definition, they still can. Remember that we just have to make choices with respect to the reward function. You can imagine a world where all I know is how happy I am, but I have no other information about the world. Except I also know what I'm doing. So I can also take actions. So imagine there's 4 levers, and one of the levers makes me happy. The intelligent thing to do would be to pull the happiness lever. And you can imagine in a situation like this, if my choice is just which lever to pull, I can pull any lever. I might explore a bit and pull the different levers and see what they do, and then just keep on pulling the happiness lever. And that's my optimal strategy. And that's still an intelligent choice to make, and you can still have intelligence. But it's not particularly useful or particularly interesting, because obviously it can't learn that much. Can you have an intelligent system without a reward function? Can it be a tabula rasa intelligent system or robot? No, you can't. The whole point of the intelligence is that it's making choices with respect to its reward function. It's making choices about what output to do. If we don't have a reward function, how can we pick between our outputs? We may as well just be outputting random things. And that's not intelligent. You lose the ability to choose if you don't have a reward function guiding your choice or saying why any particular choice is better than any other choice. Can you have an intelligence without any outputs? This is an interesting one. Because by my definition, you can't. But still, I can imagine a situation where there's a kid in a coma lying on a bed and his mum each day comes and reads him a story. The kid could still be intelligent. The kid could still be processing information. But from the outside point of view, without actually knowing what's going on in the kid's mind, there's no way to tell. We can't judge, and we don't have any information about whether or not the kid is actually acting intelligently. So, yeah, I mean, they're indistinguishable from, say, someone who's in a vegetable state and is completely incapable of processing new information. And fundamentally, that's because they don't have the ability to choose, because there's no outputs they can perform. Mind you, you can imagine a situation where you've only got inputs coming in, and still sort of being intelligent. I mean, if you've got the world giving information into your intelligent system, then you can still be understanding that world kind of thing. And you could, if you wanted, say, attach some electrodes to their brain and see if they're still making predictions about what's going on in the world, and based on the information they get. I'm going to talk a lot more about this later, because it's a model that I'm going to be using at least for the first part of my PhD. Although it doesn't particularly perfectly fit with the definition, it's still a useful model or a useful way to think about at least the input part of the intelligent systems. Finally, can you have an intelligent system which defines its own reward function? And this is actually quite a fundamental question, because if we could, then you could define a general intelligence without needing to ever tell it what to do or where to go and stuff. Unfortunately, that's impossible. And it's impossible because the intelligent system has no external reward function. And as far as the internal reward function goes, if you could change what reward values you're getting, well, wouldn't you just do this and get infinity reward all the time? Be incredibly happy, crawl up in a corner and die? Ultimately, no choice or no action that you actually do is more valuable than any other choice, because you're in a state of complete ecstasy all the time. And there are some people who talk about this, and they talk about wire heading. Plug a wire into your brain to do exactly this. And yeah, I don't really know what to think about it, but it's interesting. And it's interesting from a sort of intelligence point of view. So ultimately you can't. It doesn't work, because it's the same as having no reward function at all, and your choices would be completely random. After the break, people.